Let's do an example where we use reference numbers to evaluate some other trigonometric functions. Our strategy is going to be almost exactly the same as the strategy we used previously for sine and cosine functions. That was, we will find the reference angle, t prime, and we'll need its terminal point, a comma b. Again, just like in the case of sine and cosine, we can't use this method unless we know what the terminal point is for the reference angle. Then the terminal point for t will be plus or minus a, comma plus or minus b, where we choose the sign, S-I-G-N sign, based on the quadrant. And then finally, we'll use the definition of the relevant trigonometric function, whichever trig function it is. In these problems, almost all of the work lies in the first couple steps. Okay, so let's start with A. So we want to know what is tangent of 8 pi over 3. So in order to figure out tangent of 8 pi over 3, first we need to figure out what is the reference angle of 8 pi over 3. Of course, we spent a good bit of time finding reference angles. That was a topic in and of itself in previous videos. Remember, we'll first look at our angle here, and we will add or subtract 2 pi if it does not already lie in the range of 0 and 2 pi. So let's see, is 8 pi over 3 larger than 2 pi? Well, 2 pi, if you multiply by 3 over 3, you get 6 pi over 3. So 8 pi over 3 is larger than 2 pi. And so I'm going to subtract 2 pi from 8 pi over 3. I subtract 2 pi and I get 2 pi over 3. Again, noting that 2 pi is the same as 6 pi over 3. Now remember, 2 pi over 3, that's not the reference angle. That's what we'll use to figure out the reference angle. And of course, if you have to go in your notes back to the previous videos, then please take a look at how we found reference angles in those previous notes. So now 2 pi over 3 is in fact between 0 and 2 pi because, again, 2 pi is 6 pi over 3, and certainly 2 pi over 3 is less than 6 pi over 3. So now that we have something that's between 0 and 2 pi, we'll go ahead and figure out what quadrant this lies in. So 2 pi over 3 is certainly bigger than 0. Is it larger than pi over 2? I suppose we don't know yet. We can get a common denominator, multiply by 2 over 2 and by 3 over 3. And this left-hand side becomes 3 pi over 6. And this right-hand side becomes 4 pi over 6. And indeed, 4 pi over 6 is larger than 3 pi over 6. So the conclusion would be that pi over 2 is less than or equal to 2 pi over 3. And 2 pi over 3 is going to be less than or equal to pi. Reason being is that 2 is less than 3. But if you needed to compare, you could multiply by 3 over 3 and get 3 pi over 3. So we know we lie in quadrant 2 because we're between pi over 2 and pi. Remember what we're doing here. We're doing our first step, which is finding our reference angle and its terminal point. So now we know we're in quadrant 2, and we can now draw a picture of what this looks like. Could just do a quick sketch here, and we'll write an equation for what it means to be in quadrant 2, to be a t value in quadrant 2, or a t angle in quadrant 2, and we'll draw in the reference angle, t prime. Now in my picture, I see if I go around by t and then a bit further by t prime, then I get to doing a total of an angle of pi. Pi is halfway around the circle. And so t plus t prime would have to be pi. And so I know that my reference angle, t prime, is pi minus t. And in this case, remember, you use the t that's between 0 and 2 pi. That is, in this case, 2 pi over 3. So here we have that our reference angle would be pi minus 2 pi over 3, which is, getting a common denominator, the first term would be 3 pi over 3 minus 2 pi over 3 is just pi over 3. And this reference angle, pi over 3, is in fact one of those special angles in the first quadrant. It has terminal point, which is 1/2, comma, root 3 over 2. So at this point, we have found t prime, the reference angle, and its terminal point. And now the terminal point for the original t, that is my 8 pi over 3, that is going to be plus or minus the x-coordinate for the terminal point of the reference angle, 1/2, comma, plus or minus the y-coordinate here, which is root 3 over 2, where we choose plus or minus based on the quadrant. Now we're in quadrant 2, so that means that the x values are negative. You don't have to memorize this, you just have to be able to look at let's draw a picture here. Quadrant 1, 2, 3, 4. And in quadrant 2 over here, the x-coordinates are negative and the y-coordinates are positive. So x is less than 0, so pick negative here, and then the y-coordinates are positive, so we'll pick y bigger than 0. And so our terminal point for 8 pi over 3 is negative 1/2, comma, root 3 over 2. And so finally, we can evaluate tangent of 8 pi over 3. We just simply take the y-coordinate, which is root 3 over 2, and we divide by the x-coordinate, which is negative 1/2. And so this is negative root 3. And actually, at this point, it's not very much work to evaluate all the other trigonometric functions. So if you wanted to know what cosecant of 8 pi over 3 is, you don't have to do all that work over again. We have what the terminal point is for 8 pi over 3, and we can use that to evaluate cosecant of 8 pi over 3. Now remember my tip, the cosecant function, it's a secant function. It's paired with one of the original functions, and since it has a co, we're going to remember that it gets paired with the original function without a co. So this is similar to the sine function, and the sine function is the y-coordinate. So this is going to be 1 divided by the y-coordinate, 1 divided by negative 1/2, which is negative 2. And again, I won't do this here, but you could figure out secant of 8 pi over 3, cotangent of 8 pi over 3, sine and cosine of 8 pi over 3, all of the trigonometric functions. You've done all the hard work, and you can simply just use the definitions of the trigonometric functions to evaluate each one of them if you would like. Now, the second part said to evaluate secant of 120 degrees. So let's do the same thing. We'll go ahead and we'll find the reference angle first. Now, we should make sure we're dealing with an angle that's between 0 and 2 pi, or in degree form between 0 and 360 degrees. And in fact, we do. 120 degrees is between 0 and 360 degrees. And then we'll establish what quadrant 120 degrees is. Well, 120 degrees is between 90 degrees and 180 degrees. And of course, that means we're between this vertical positive y-axis and this horizontal negative x-axis, and so again, turns out we're in quadrant 2. And you could draw a picture of what that looks like, but we already drew a picture of an angle in quadrant 2. That's here, and we figured out that t plus t prime is pi. So 120 plus t prime has to be pi, but we're in degrees, so this has to be 180 degrees, because pi radians is the same as 180 degrees. And so the reference angle is going to be 60 degrees. It just so happens that for this problem and the previous one, the reference angle is the same. We're just working in degrees instead of radians. So the terminal point is 1/2 comma root 3 over 2. The terminal point of 60 degrees, so let's write that down. Of 60 degrees is 1/2 comma root 3 over 2. And thus the terminal point for 120 degrees is equal to, again, plus or minus 1/2 comma plus or minus root 3 over 2. And again, in quadrant 2, the x-coordinate is negative, the y-coordinate is positive. And so finally we have the terminal point for 120 degrees, and we can figure out what secant of 120 degrees is. So this is one of the new trigonometric functions. It's going to be similar to one of the original ones, and the secant doesn't have a co, so it's similar to the original one with a co, that is the cosine function. And the cosine function cares about the x-coordinate. So this is going to be not x, but 1 over the x-coordinate, which is 1 over negative 1/2, which is negative 2.